Welcome to Programming in Modern C++. We are in week 3 and going to discuss module 13. In the last module, we have primarily covered the information hiding feature of object oriented programming, how to implement that in C++ classes by making the implementation, the data members private and exposing the interface, the member functions that people need to use, making them public, and we have talked about get set idiom. We will now get into the very depth of how do we start the whole process of object creation and how do we end that life of an object. So, we will talk about the constructor and destructor, which I have already mentioned couple of times in my earlier modules, but now you will actually learn what it does. So, starting with the constructor. So, this is what we had seen, that this is what we should not be doing, and the exposed initialization, the risk, we have seen all of that. So, we are in this style of information hidden design, where the data members are in private and only the member functions which the interface needs are in public. Now, there is a in this there is a border. The border is that when I say stack S, obviously I will have an array of data, I will have the top, but what about the value of top? That needs an initialization, right, which I was doing here directly. So, instead of doing that, which exposes the initialization, I will add another function. I may add another function to the interface called init, and so using that function the user can initialize the stack. So, I do s dot init. Now, there are this obviously is cleaner than what you had here, it is better, but it still has a couple of very critical problems. One is this has to be called before the first of any of these operations in the stack can be done, right. User has to remember doing that. Second, it should never be called after that, because the moment you call this, it is like flushing the whole stack out, right. So, that again, I mean this with the information hiding, this does give us a programming way to handle the situation of initialization, but it is not a very preferred way, because it can still cause lot of possible errors and make things unsafe. So, if we compare this, so this is the init we had said, and this is what has to be called, what you just saw. Now, the C++ allows that you can write a constructor. A constructor is a special function which has the same name as the class. So, why do we have that? The reason is simple. I need to initialize, and I need to initialize every object of every class that I create. Now, if I let users give name to the initialization function, then somebody will call it init, somebody will call it start, somebody will call it initialization, there will be all confusion, and how will the compiler know? So, give it the name which is same as the name of the class, because the name of the class is unique, right. And the important part is, when this is declared, the control is passing this point, then this constructor is automatically called. What is automatically called? The compiler knows at that point that unless stack S has been declared, S dot push cannot be done, because S is no more, not even an object. But once this has been declared, from the next point onwards it can be used. So, at the declaration point it puts, which we do not get to see, puts a call to that constructor. So, if you put all your initialization within the constructor, then it will automatically get constructed. You do not have to do anything. There is no question of forgetting it, there is no question of doing it multiple times, there is no question of doing it at a wrong point, any of this, everything gets solved, right. So, that is a basic idea of the constructor. Mind you, in the constructor we are using here, this was an assignment, right. We are assigning this. Here what we say, we are doing an initialization. This actually is a constructor body which has nothing. It can have something, but in this case it has nothing. So, what we say, we put the name of the data member and we put the value within parenthesis that we want to initialize it with. That way it gets a lot of advantages. We will see those advantages slowly more and more, but the biggest advantage is that it is very clearly available at one point, and very clearly I cannot actually get into the executing the body of the constructor, because till all data members that need to be initialized are properly initialized, I do not have a proper state of the object, right. So, that is the purpose of the initializer list. So, we will come to discuss that more in depth later. So, for example, the examples of stack constructor, here I have given the constructor. Outside of the class, it is qualified by the class name. I initialize top because this is an automatic array, whereas here it is a dynamic array. So, in the constructor I initialize stop, but I also need to dynamically create an array and put that pointer to data. So, whatever internal structure I may have, whether I have a static array, automatic array, or I have a dynamic array, or I have a linked list, whatever I do, I do not need that to be exposed. All that the compiler knows, I say stack S. So, the constructor will have to get called, that is it, and it will do the job, makes it a very, very clean solution. So, if you just see what is the difference between a constructor and a member function, because constructor is also a member of the class, right, because it is specific to that class, has that specific name. The first thing to remember is, and we will talk about this more later, is it is a static member function, in the sense that see, the problem with the constructor in comparison to other member functions is, all other member functions are invoked after the object has been constructed, all initialization is done. When you are calling the constructor, the object is not constructed, because that is the purpose for which you are calling it. So, the object, there is no initialization. So, but the constructor needs to know the address where the object will reside, because without that address it cannot put values to data members, like it is saying top underscore will be initialized with -1. How will it put it in which memory? So, it has to know the memory where the object will come, but that memory pointer has still not become a this pointer. It becomes a this pointer only when the object is been born, has been created by the constructor. So, the constructor is implicitly independently called, and that is what is the important thing, and data members do not have that. So, this we have already said, this is the same name as the class, member functions must have different name. Constructors do not return anything. Not only that, they do not have a return type, even it is not even void, because there is its construction is a process which establishes the object, and then the control has to come back. There's nothing else. It cannot come back with anything, or there's nothing required to say that there is a void return. Nothing is returned. So there is no return, and therefore there is no return statement either. The control returns implicitly, whereas in case of member functions, the return return may be there, it may not, may be implicit, it may be explicit, whatever. So initializer list is there, and this is specific to the constructor. Such lists are not available to other functions, not member functions. It is implicit by instantiation, whereas member functions have to be explicitly called. Constructor may also be private, and we will, that is another paradigm of information hiding that we will talk of, that it might wonder you as to what will happen if constructor is private. What am I trying to say? I am trying to say that I do not allow you to construct an object. Well, if you do not allow the user to construct an object, then how will the user at all use the service? Well, there are answers to that question, but that's another very strong paradigm of programming that we will get into. So typically in the initial part, we will always have constructors which are in public, but it can be private also. Member functions can be public or private. Both can have any number of parameters, and both can be overloaded. We will see these things slowly. So this is the basic. I just wanted to outline the differences between a common member function and the. Okay. So you can have parameters to the constructor, like any other than the initializer list, and not having a return type and having a fixed name. Other than that, every rule of the function applies there. You can have parameters, so I can pass the specific values. So when I write C 4.2 5.3, then this goes as the first parameter, this goes as a second parameter. In stack I did not need that, so there was no parameter, because in stack the initialization is by known values always, whereas here I need them, so I can put these parameters. And the moment I can put parameters, then all related stories will come, stories of function will come with that if I can put parameters, then parameters can be defaulted. If parameters can be defaulted, then a constructor can be invoked in multiple ways. This is just like following the rules of function, default parameters in functions. So if I have defaulted both the parameters, so I can just instantiate it with only one, which will be the RE, or instantiate it with both, which will be RE and IM. Right? So there is nothing new in this over what we have already seen in the functions. Now here is a stack with a default parameter, which is the initial size of the stack that I provide, and accordingly in the constructor the allocation is done for that size. So these are different ways you can use it, the parameters once you have. Now once you have the default parameters, you can understand that like in functions you can have overloading. So it is not necessary that a constructor will have only, there will be a unique constructor. There could be multiple constructors. For example, here I have shown 3 constructors, one which takes 2 parameters, one and one which does not take any. Right? Accordingly, you have 3 possible invocations or instantiations of the objects. So all overloading rules, all that as we had seen earlier, will apply. So this is the overloaded constructors for rectangle. So here what we are saying, we are passing 2 points. This becomes a rectangle. Here what I am saying, I am passing a point and a height and a width. Right? So this will also become a rectangle. A very different way of passing the rectangle. Here I am just passing height and width, height and width. not the left top. So, I have to assume a default. So, I am assuming that left top is 0 0. So, there are different ways I can construct a rectangle, and there are different constructors for that. I have to make sure that they are distinguishable by the number and types of parameters. That same issue of overload resolution will come in here, and here I have different invocations of these constructors for building the rectangle objects. Okay. So, that is about the constructors. Now, let us move on to the destructors. Destructor does the other thing. Constructor has constructed the object. So, if you think in terms of C style, then you will say, okay, I had constructed. So, this allocation was done. So, I need to release that. So, I have a deinitializer which should release that memory, and that should be called at the end. Again, the issues are the user will forget, right? And if the user forgets, then the data leaks, or if the user calls it twice, then you may have different kinds of pointer referencing issues and so on. So, what the C++ provides, it provides a destructor which also is the class name preceded by the tilde symbol. That is a peculiar way of naming it, which you do not use anywhere else, and that will get called at an appropriate time. So, you have declared the stack here. So, here the constructor has got called. Now, the compiler knows the scope up to which the S can be accessed. Before this, S does not exist. So, there is no object either. After this point, after the control passes this point, you go out of this scope, you go out of this function. So, naturally there is no S. So, it is only up to that point. So, at this point it will invoke the destructor automatically. Absolutely clean solution. You have to do nothing. You have to do nothing other than just declaring that you are using a stack S, and then go and use it. The compiler has automatically constructed, compiler will automatically destruct. Beautiful solutions. So, if you just want to compare with the common member functions, then both destructor has a this pointer because the object is existing. The name is as I said, tilde followed by the class name. For member functions you do not have that. Like constructor, destructor also does not have a return type, neither, not even void, because it is because you destroy, after you have destroyed, the object is gone. So, what will you return? I mean, there is no concept of a return, whereas all those are standard for member functions, and it is implicitly called at the end of the scope or by operator delete also. So, we will see that kind of scenario soon. And so you can make a note that since the destructor will have to actually tell which object it is destroying. Okay? Constructor did not have to do that, because constructor did not have an object. It just needed a memory, which compiler makes a mechanism to pass that memory pointer to the constructor. But when you are destroying the object, say S. So, you have to pass this pointer of S, which by the implicit mechanism the compiler will pass exactly like it passes to the member functions. Again, destructors could be public or private. It does not allow parameters, for the simple reason that what will a parameter mean? Parameter mean that you are trying to say something to be done, right. But when this is being called, nobody is calling this, no user code is calling this, it is being called implicitly and at the end. So, in that implicit call, how do you pass a parameter? Like in the constructor, it was possible, because it is automatically called, but it is explicit. You know where it will be called. in case of destructor, you know it will be called, but there is no call site that you can see, it is not visible. End of scope, compiler has put this in, it may have put in hundreds of such destructors. So, there is no sense, neither a mechanism, neither a possible syntax to pass parameters to it. So, the destructors will never allow parameters. So, and obviously, it cannot be overloaded. You cannot have two different destructors, because again how will the compiler know which one to call? If you overload, you need parameters. So, if you cannot have parameters, you cannot overload it. So, these are some of the basics about destructors. Okay. There is a special type of constructor. A constructor without any parameter is called a default constructor, right. Now, so actually if you define a constructor and default all its parameter values, then also you are actually having a default constructor, because it is possible to call it without any parameter, right. But you can choose not to have a default constructor. Now, what happens is when you do not, if you write a class and you do not give a constructor. Now, there could have been two choices. One is this could have been made not allowed at all, so that the code will not compile unless you give a constructor, but that has not been done, because there are several small situations where the constructor is so trivial that you would not like to take the pain of writing it. So, what does the system do is, if you do not provide any constructor, the compiler will supply a default constructor, a constructor without any parameter, without any code, without any initialization, but it will provide that placeholder function. Okay. And once you write a constructor which is either I should say default or is non-default, that it has parameters only. Once you write that, the compiler will not provide it. Similarly, for the destructor, if you write one, then the destructor will not be provided by the compiler, but if you do not, then the compiler will provide a destructor. It is very common that we do not write destructor, because if there is no dynamic allocation usually, then there is no need to specifically do anything when the object is going out of scope, right. The automatic scoping will take care of it. So, so the compiler will in every such case, compiler will provide a default destructor. So, you can, whether or not you write a constructor, whether or not you write a destructor, this guarantees that every class, when it's after its compilation, has a destructor, has a constructor, at least one, and has a unique destructor. Okay. So, that is now. So, this is the example of a default constructor by the user. I have explicitly written that. So, the construction is done here by default values. Now, let us see if I do not provide it. Here I have no constructor I have given. Since I have not given a constructor, what will happen at this point? The compiler will give a default constructor. Now, that default constructor does not know what to put here. As I said, there is no initializer list, there is nothing in the function. It is just a blank function with no parameter, right. So, after the object has been constructed, just for experiment, if you try to print to see what kind of things it has, if you do that print, you will find something like this, garbage values, of course. So, then you will have to, then you use your member function to set it to proper values, doing this set on RE and IM, and then do the print, you will get the proper one. Right. So, remember this, that the free constructor that you get may not always often satisfy what your actual needs are. Okay. Now, with this, let me get into the basic lifetime issues. That is, it is clear that an object does not exist in the system all the time. Right? The object exists between object creation and object destruction. Right? Now, naturally, this notion is not specific to C++. It has in several languages this concept is there. It is called object lifetime or life cycle, but the meaning of that may vary from time to time. For example, in C++, the object lifetime primarily denotes primarily relates to, coincides with the variable lifetime. The variable is in the scope, the object is there. When the variable is no more accessible, the object is not accessible. But that may not be true again if you have dynamically created objects, because the variable which created that object, held that, pointed to that object, may go out of scope, but you may have passed that pointer to someone else. So, you continue to have that object. So, the lifetime will, because the lifetime is from object creation to object destruction. Similarly, other languages like Java, Python have garbage collectors. So, the object goes out of scope, it is notionally not there, but it actually exists till the garbage collector removes it. So, based on that there are so in the C++, it typically is certainly you have allocation, the construction, allocation of the stack frame, the construction, the use and the destruction, right. So, I have marked by E1, E2 through E9 in this code to exactly how the object is taking part in the flow. So, I would request you to carefully study each one of these from this chart and make a clear understanding of what the objects are going through. So, at the top level, first the memory has to get allocated and bound for this object, then the constructor has to get called and constructor will execute, then the object is ready, object will be used, then the destructor will be called and executed. So, destruction part is done, then it has to be debinding and deallocation for the whole thing. Right. So, the basic construction object lifetime considers is it starts with the execution of the constructor body following the memory allocation, but constructor body, mind you, the initializer, when as long as the control is in the initializer list, it is not considered that the object lifetime has started, for the simple reason that if you have that lifetime there, you still do not have a valid state. So, say your array has been allocated, but for a stack, but top has not been initialized. So, the object is actually not there. So, after the initialization list, so you have this. After the initialization list, when you are at the beginning of the constructor body is when your object construction has started, and your object destruction will be considered to have happened when as soon as the control leaves the destructor body. Okay. So, this is the simple notion of the lifetime. In the following slides, I have provided the examples for what happens in case of automatic variables, like in here these are automatic. So, you have this, you have already seen. Naturally, it is constructed here and destructed, and you remember the destruction will always happen in the reverse order. If there are two, it is constructed as C D and it is destructed as D C. So, you can think of it as if as a stack. So, it is last constructed, first destructed is always the mechanism, right. That is all through C++. So, it could be automatic like this, it could be array of objects. If you have an array of 3 objects, then there are 3 construction calls. And one point to note is, if you want to construct an array of objects, you must provide a default constructor. Right. So, three constructors called C0, C1, C2. So, it will destruction will be C2, C1, C0. If it is static, then it will be constructed before main starts. This is something which is possibly new to you, but remember that all static variables have to get initialized before main starts. So, now there is a construction. So, the static object will get constructed. So, I have given the programs in a way, and the output will clearly tell you where the lifetime is going. And finally, if you have dynamically created objects, then it is up to your control as to when you construct by new and when you destruct by delete. So, please trace this codes carefully to understand more about the object lifetime. We have talked about the constructor and destructor, the two basic most important functions in a class. So, I hope you have understood this, and you will need to revise on this very frequently. Thank you very much for your attention, and we will meet in the next module.